I was just watching the movie Wedding Crashers, and there's a scene where Owen Wilson's on a boat, and he's getting his directions on the boat mixed up, right or left, or I think it's starboard, or I forget what the other one's called. But this is bad because he's pretending that he's a sailor. So the excuse that he makes is, oh, he learned to sail down under, where everything is backwards. Like even the toilets spin in an opposite direction, and it really freaks you out the first time you see it. Now, this is a common myth and he's referring to what's called the Coriolis effect, which is why hurricanes spin counterclockwise in the Northern Hemisphere and clockwise in the Southern Hemisphere. The only reason it's a myth, though, is because it doesn't actually work on a small enough scale to impact the rotation of toilet spin, but it does impact a number of different things in our lives, like hurricane spin, to transportation, to ocean circulation. So I thought it would just be interesting to see what is true about the Coriolis effect and dive into the science behind it. So what is the Coriolis effect and how does it affect our world? Have you ever wondered why hurricanes spin in different directions in the Northern and Southern Hemisphere, or why airplanes have to adjust their routes when flying over long distances? The answer lies in a scientific phenomenon known as the Coriolis effect. You may not have known that about airplanes, but it is pretty interesting that they actually have to account for the spin of the Earth when they're plotting their path that they're going to take through the sky. Now, just continuing, what is the Coriolis effect? The Coriolis effect is a result of the Earth's rotation on its axis. As the Earth spins, objects in the atmosphere and on its surface are deflected to the right in the Northern Hemisphere and to the left in the Southern Hemisphere. This happens because the Earth's rotation creates a horizontal force that deflects objects in motion. Now, as I'll explain in a minute, it's a little misleading to call this a force and to say it's deflecting objects, because in reality, the objects are actually going straight. It's just the plane underneath them that's moving, and it gives the appearance that the object is curving when it's actually people on the ground that are the ones that are moving. Now, I'm sure that just made no sense, so the metaphor coming up explains it a little bit better. So to understand this effect, imagine a ball rolling on a spinning merry-go-round. When the ball is thrown towards the center of the merry-go-round, it appears to curve to the right in the Northern Hemisphere and to the left in the Southern Hemisphere. The same effect happens with air and water moving on the Earth's surface. That wasn't the best way I've ever heard this metaphor. I think it's called a metaphor for the Coriolis effect. The one in the textbook that I was reading was a little bit better, so I'll try to explain how they did it. So imagine you're on a merry-go-round and your friend is sitting directly across from you, and the merry-go-round's not moving. You roll the ball, it goes straight to them, you roll it back and forth, nothing surprising there. Now let's say the merry-go-round starts spinning counterclockwise. So this is like if you're up in space and you're looking down on the Northern Hemisphere. Looks like it's spinning counterclockwise. Now, if you roll that ball to your friend, it's going to look like the ball is curving to the right. Now, what's weird about this, and is kind of the catch, is the ball is actually going in a straight line, but it's the merry-go-round and the people that are moving. So from their perspective, they're staying still and it looks like the ball's moving and curving. But in reality, it's actually them. Now, it's the same thing with airplanes. The airplane looks like it's being curved to the right in the Northern Hemisphere, but it's actually the Earth underneath the airplane that's spinning. So it's a matter of perspective, and that's often why you hear this referred to as the Coriolis effect, not the Coriolis force, because a force is something that directly acts on an object, whereas this is more of like a perspective issue, and it looks like there's something acting on the object. Now, the reason it spins the opposite direction in the Southern Hemisphere is that's just like our merry-go-round is spinning clockwise now. Because if you're in space and you look at the Southern Hemisphere, looks like it's spinning clockwise. So if you roll that ball to your friend now, it's going to look like it's spinning to the left. But it's not actually curving to the left. The people are moving. So just continuing here, how does it affect our world? The Coriolis effect has a significant impact on weather patterns, ocean currents, and transportation routes. For example, hurricanes and typhoons spin in opposite directions in the Northern and Southern Hemispheres due to the Coriolis effect. In the Northern Hemisphere, hurricanes rotate counterclockwise, while in the Southern Hemisphere, they rotate clockwise. Now, here is where things get a little bit confusing. So I'll just keep reading. See if you can pick out what's confusing about this. Similarly, ocean currents are affected by the Coriolis effect, which causes them to rotate clockwise in the Northern Hemisphere and counterclockwise in the Southern Hemisphere. This rotation creates a circular motion known as a gyre, which affects global climate and ocean ecosystems. So I think with the ocean currents, this makes perfect sense. Like, you think of the Gulf Stream going up the East Coast. If you had water flowing in like this, Coriolis effect curves it to the right, and it spins in this clockwise motion. I'm not sure if the camera flips it. Maybe I should be going like that. But yeah, Gulf Stream comes up the East Coast. It completes the circulation around the Eastern Atlantic, and then it looks like a big clockwise circle. That one makes sense. But then hurricanes in the Northern Hemisphere spin counterclockwise. So it seems like the same effect, Coriolis effect, is leading to two different circulations, whether we're talking about water or we're talking about air. Now, the reason for this is extremely difficult to put into words. This is actually, I think, my fourth take of this video, because in the past I've tried to explain this in words. So I think I'm just going to say, I will actually just work this out on my iPad, almost like a whiteboard, so I can actually draw the different forces that are going on. But the basic reason is because when we're talking about a hurricane or a low pressure system, the Coriolis effect isn't the only force that's acting on the wind. You also have the pressure gradient force. And how those two forces interact with each other ends up leading to that counterclockwise motion. I'm sure that made no sense saying it in words, so I'll try to make that one a bit more visual in another video that I'll do. You can find that on my channel. So just continuing here, the Coriolis effect also affects air travel, as airplanes have to adjust their routes to account for the Earth's rotation. When flying from east to west, so New York to San Francisco, airplanes have to adjust their heading to the north to compensate for the Coriolis effect, which deflects them to the right in the Northern Hemisphere. Conversely, when flying from west to east, airplanes have to adjust their heading to the south. So you can think, if you're flying from San Francisco to New York, the Coriolis effect is going to seem like it's curving the airplane to the right. So the pilots have to take that into account when they're making their course. Not something that is exactly intuitive, or that you've probably thought about air travel, that they have to take into account the spin of the Earth, but pretty interesting. And I imagine it's the same is true for like long-range missiles or anything that happens over a very large area. Not so much as small as a toilet, but things like flying all the way across the country, you do have to take this into account. So in conclusion, the Coriolis effect is a fascinating scientific phenomenon that has a significant impact on our world. It affects weather patterns, ocean currents, and transportation routes, and its influence can be seen in many aspects of our lives. By understanding the Coriolis effect, we can better predict weather patterns, navigate transportation routes, and appreciate the beauty and complexity of our planet. So, basic summary there. Things curve to the right in the Northern Hemisphere, curve to the left in the Southern Hemisphere. That's called the Coriolis effect, and that's the reason hurricanes spin in different directions depending on which hemisphere you're talking about. Although hurricanes are on the very large scale, things as small as your toilet bowl do not get affected by the Coriolis effect. So as great of a movie as Wedding Crashers is, that was in fact a lie. Although we'll give them that because it is just a great movie. So hopefully you learned something throughout this video. I know I did. And thanks for watching.